Hi class, this is going to be the second part of section 5.3 in your textbook, and it is going to be about trapezoids and the properties that trapezoids have. So first of all, let's remember what the definition of trapezoid is, which you learned back in chapter 1. A trapezoid is a quadrilateral with one pair of parallel sides. So a four-sided figure with one pair of parallel sides. You need to remember to make your markings on your figures to show which sides are parallel. Those parallel sides are called the bases. So you can see the little picture that is on the screen here. Notice the parallel mark showing that the bases are parallel. Okay, so we're going to construct a trapezoid in Sketchpad. So go ahead and open up Sketchpad. I have a few other things open here. So let's start with a new sketch. And we want to construct a quadrilateral that has two pair of parallel sides. So let's start with one line segment. We want to pick a point not on that segment and construct a line parallel to this segment. So I'm going to highlight the two of them and say construct parallel line. And so now all I need to do is make two other points on this line and construct segments. To make my trapezoid. So finish up your trapezoid, and what I want to do once it is constructed is to measure the four angles in our quadrilateral. So notice I can make this trapezoid. We don't want to make it a parallelogram, but this is still a trapezoid as long as it has one pair of parallel sides. Now I can mark my parallel sides. I will make an arrow. I don't need this point here, so I'll draw my arrow through it. Okay, to show that they're parallel. Now I am going to measure my angles. Measure all four of them. And see if there is something special about the angles of a trapezoid. Okay, so there are my four angles that are measured. Now, do you notice anything special about them? Look at angle A and angle B. Let's see what happens if I add those two together. So I'll highlight angle A, and I'm going to add to it angle B. I'm making a video, Ty. Wait just a minute. So those two angles are supplementary. So angle A and angle B. Now, they're not both base angles. One of them is down here. They are both base angles, but not to the same angles. Now let's see if the same thing happens with angle C and angle D. So I'm going to open my calculator back up. So I'm going to highlight angle C, and I'm going to add to it angle D. And look what happens there. So these two angles are also supplementary. I hope the same thing happened when you constructed your trapezoid. Let's take a picture of this and we'll put it in our notes. Okay, so let's write some conjectures having to do with trapezoids. The first one is going to be the consecutive angles between the bases of a trapezoid are, what do you think it's going to be? The consecutive angles between the bases of a trapezoid. What did we just decide when we measured those? Yes, they are supplementary. So let's fill that in with supplementary. That is conjecture 38. This is section 5.3. So consecutive angles between the bases of a trapezoid are supplementary. The next two conjectures having to do with trapezoids are if they are isosceles. So they have two congruent sides. So the base angles, if our trapezoid is isosceles, they will be congruent. So conjecture 39, we are going to fill this in with congruent. Base angles of an isosceles trapezoid are congruent. You may want to try to make your trapezoid an isosceles trapezoid or construct one. So in this case, if I measure the lengths of my sides, these two sides are the ones that would have to be congruent in order to make it isosceles. And you can see there that it's not quite isosceles, so I'm going to drag point D until they are isosceles. And then when I do that, look at the measure of angle A and angle D. Because I did not construct it as isosceles, it's slightly off. Okay, but you can see where the base angles in an isosceles trapezoid will be congruent. A and D would be the base angles, and B and C would be the other pair of base angles. Okay? And then our last conjecture having to do with trapezoids are about the diagonals. So the diagonals of an isosceles trapezoid are blank. Well, let's see what happens. If I go back into this trapezoid and I construct a diagonal between B and D, and then I construct the other diagonal, and then let's measure them. Again, it's slightly off because I did not construct this as an isosceles trapezoid, but the diagonals will be congruent. So there are three special things that happen with the trapezoid, three conjectures. this being the third one. So the diagonals of an isosceles trapezoid are congruent. And that concludes all of the information that you need to know from section 5.3. I'll see you in class tomorrow.